Back with another Python question. Probably gonna do an assessment and then I'll just discard it if I run out of time and have to do something else. But I'm probably gonna do, yeah, well, we did this one last time. I probably don't have an hour and a half, but there's 3 questions, so I'll just split the video up in between each one. So let's see. All right, given a fixed length integer array, duplicate each occurrence of 0, shifting the remaining elements to the right. Not written. Do that in inventory and don't return anything. Oh, okay. So do something in place. Duplicate each occurrence of 0. I see. So, okay, so let's think about how to do this problem. So, you know, length of this array is something equals something. What do I want to do? Like, I want to detect if this is 0. If it's 0, I want to do something. Namely, if I'm a 0, namely, like before the first 0, I'm just chugging along. I don't do anything. When I detect a 0, I want to put another 0 in the next element. And then I want to just keep copying the elements until I hit another 0. But then if I hit another 0, I need to be able to basically write like a couple more zeros. So I'm wondering, like, so if I hit a 0 here, right, and I see a 2, that's next, I might store that 2. Do the above modification in place and do not return anything. So this doesn't mean that I can't have a buffer to say, like, well, I should memorize this 2, because if I need to write a 0 here, then I need to remember the 2, so that when I write a 0 here in this next iteration, I'll know the iteration after that I'll need to write a 2, and then a 3, and so forth. I'm wondering if there's a cleverer way to do this. Where if I go from right to left, what happens if I go from right to left? Is there a cool way to do that? Or if I run through the entire array and I count the number of zeros, is there a way, you know, for me to do anything with that information? So for example, if I'm the first 0, I know everything, I'm going to shift everything by 1. So let's say I'm index 1, then how many zeros can there be? So one way to do it is to make many passes through the array. So for example, I detect a 0 and I just put a 0 in. And when I put a 0 in, I'll just copy the next element over. And I'm just gonna do like 2, 3, 0, 4, 5, that. And then I'll just remember the previous index of the second 0 that I put in, and then start again over here. And then just, do the same thing again and again until my, until I'm at an array. Yeah, I feel like there's a clever trick I'm just like missing. Okay, so I think what I might do is I will count all the zeros in the array, and so in this case it'll be 3 zeros, and I'll start at the end. And if it's 3 zeros and it's if it's a 0, so if I run into the first, let's say this wasn't a 0 and there's 3 zeros, then I would move this to the right by 3, and if it's out of bounds, I don't do anything, basically. And if it's a 0, yeah, I guess 0 or not, I do want to do that. So I would have moved this by 3, but it would have been out of bounds, so I don't really do anything. Here it's a 5, and then so after I get past the, like for every 0, so I might start with a counter of 3. So for example, here, then I'll say, well, I'll start with 3 num zeros. It would be 3. I'd move 3, and then after I detect and move my things, so I do something, which is namely to shift this to the right by x, Like in this case 3, I don't see anything, but if this was a 0, then I would do subtract by 1, because after I get past the 0, I would need to move this by 2. This would also be out of bounds, so I go here, I move this by 2, I say, well, okay, this index, so look ahead 2 indices, it's actually inbound, so it's a 4. So I would write a 4 here. But how do I duplicate the zeros? If I'm a 0, then what? If I do see a 0, I would do the same thing, move it to the right and write this element, but I'll also write this element. So my num zeros is like, so if the, this index plus num zeros, in this case 2 is inbounds, I write this, but then I also do, I also write in num zeros to, I also write a 0 to num zeros minus 1. So I have this index I plus num zeros, and then I plus num zeros minus 1, I'll also write a 0. Okay, and then we'll decrement this again. So in this case, it'd be a 1. This would just say, okay, next element 1 is a 3, this is 2. And then here I would again do the same. I would say, okay, well, this is my num zeros is 1, so the plus 1 of that is 0, and then plus 0, so 1 minus 1 is 0 offset, and then I would do minus 1 again on my num zeros, and if num zeros is 0, then I guess I don't really do anything. And this should never hit, but you can be safe and say, like, like if num zeros, break, right? So let's try that. So here we already have the loop to figure out the zeros. So let's try the not 0 case first. That's, actually, let's just do this. So this something would be what? I need to do a boundary check. So actually, I like size better because it's a little bit more informative than L. So I'll just say like or end index, Okay, so if I plus num zeros is greater than, or greater than end index, then just continue to the next. Well, actually, basically if it's inbounds, then I want to have the array of num zeros equal to 0, and then I also want so in this case, right, if we have like 2, then we want is I plus 2 and then I plus 1. to be zeros and just dump it over there. And in this case, for example, we'd be out of bounds, so we don't really do anything except for doing num zeros -1. Now I wonder if it's like double zeros, right? Then what do we do? We really just do the same thing, because I feel like this algorithm, all this algorithm's doing is it's kind of going backwards and saying, well, if we're out of bounds, we're out of bounds, something will take over because I'm getting right shifted anyway, and I know the number of zeros a priori. So I'm just gonna grab, look ahead or look backwards and then just like put the elements in place. So it doesn't matter, I feel like, how many zeros you have in a row. You're just gonna shift it, and then since you're replicating the zeros, you know exactly where it'll be shifted because of the number of zeros remaining, because you're counting backwards, and then you're just duplicating it vis-a-vis these two lines. And then if you encounter 0, then your num zeros always have to be -1. So then when you're here on the next index, then you can go ahead with num zeros equals 1, and then your offset placements will be a little bit different. So this isn't a 0, so we don't have to duplicate it in this case. So for example, this was a 3 num zeros, this is 2 num zeros, so I just do this index plus 2. And so for this 1, 2, 3 case, I'll have 0 num zeros, but then it'll just break. So let's see if there's any compile or anything, and then debug from there. Perfect. Okay, let's debug this. So num zeros here should be 4, 7 won't move. And then we'll get this thing here, but this will be out of bounds because it's 4, and 3. Yeah, 4, 3. And then it'll be 3. So this plus 3 is out of bounds. This plus 2 is not out of bounds. Oh, but then I would just do this and this, right? So what's missing here? bounds. So this could be out of bounds while this is in bounds, so that could cause it to miss. But let's see if that even works. Alrighty, so that's question 1. So yeah, in the edge cases, I guess in my brain I kind of grouped together like, oh, this check would include this because if this is good, then the secondary statement is good. But what I didn't think of is the reverse situation where this is good, but this isn't good. So yeah, that was the sort of the learned lesson. But anyway, this was done within 20 minutes. So cool. I'll see you in the next one.